Hello everyone, myself Manikanta Sakla Bhaktula and my team members are Lakshman Sandeep, Pooja and Venkateswarlu. Our project name is Fruit and Vegetable Detection. And our abstract of the project is this project entails the convolutional neural network implemented in TensorFlow for fruit and vegetable recognition. The code begins by importing necessary libraries, mounting Google Drive, and pre-processing training, validation, and test datasets using TensorFlow's image dataset utilities. The CNN architecture consists of convolutional layers with max pooling and dropout for feature extraction and overfitting prevention. The model is compiled using the Adam optimizer and categorical cross entropy laws. The training phase is executed and the model's performance is evaluated on training, validation, and test sets. The training model is saved and the training history is visualized using Matplotlib. The code provides a comprehensive framework for building, training, and evaluating a CNN for image classification tasks on fruit and vegetable datasets. Here is our problem statement of fruit and vegetable detection. The problem statement is to create a CNN for fruit and vegetable recognition using TensorFlow and Keras. Our main aim of this project is to create and train convolutional neural networks for a fruit and vegetable recognition task. The code imports necessary libraries, pre-processing training, validation, and test image datasets. Building a CNN architecture compiles the model and trains it on the training set. It evaluates the model on a validation and test sets, saves the training model, records training history in JSON format, and visualization training and validation accuracy over epochs using Matplotlib. And our objective of the project is to create convolutional neural network for a fruit and vegetable detection, and we import the libraries and pre-process the training and validation and test the datasets, building a CNN model. Here is our proposed solution for the problem statement. Comprehensive script for a convolutional neural network using TensorFlow or Keras for fruit and vegetable recognition. It includes data preprocessing, model building, compilation, training, evaluation, and visualization. To improve it, consider implementing data augmentation techniques to enhance model generalization. Data augmentation can involve random transformations like rotation, zoom, and horizontal flipping, preventing overfitting. Additionally, considers adjusting the learning rate dynamically using callbacks and monitoring validation loss. The code could benefit from comments for better readability and a more detailed explanation of the model architecture. Finally, it's essential to ensure the dataset is balanced and representative of real-world scenarios to achieve a robust and accurate model. Here is our system architecture of the project. And the system deployment approach is we have to set up an environment and collect the data and store the data, and we have to pre-process the data, and we have to create a model and build a model and compile the model. We have to evaluate the model and save the model. By using visualization, we have to result the graph, and the model will be deployment. And we use the algorithm in the project is convolutional neural network using TensorFlow and Keras. Here is our deployment process. The conclusion of the project is the provided code is demonstrates a convolutional neural network for fruit and vegetable recognition. It utilizes TensorFlow and include data preprocessing, model building, training, evaluation, and saving. The CNN architecture comprises convolutional neural layers, pooling, dropout for regularization, and dense layers. The model is trained and evaluated on training, validation, and test sets. Training and validation accuracy visualizations are presented. The model achieves satisfactory accuracy on both training and validation sets. The training history is saved in both the model file and a JSON file. The code serves as a comprehensive example of building and training a CNN for image classification. Our future scope of the project is the provided code demonstrates a convolutional neural network for fruit and vegetable detection or recognition. The future scope involves enhancing model performance through hyperparameter tuning, exploring advanced architecture like transfer learning, implementing data augmentation for better generalization, and deployment the model in real-world applications, possibly in mobile devices. Additionally, continuous monitoring and improvement based on feedback can be incorporated. Exploring interpretability methods and addressing class imbalances can further refine the model. Consideration of emerging techniques and datasets can keep the model up to date, ensuring its effectiveness in diverse scenarios. Integration with web or mobile applications for using user-friendly interfaces could extend the practical utility. Here is our reference link. It is the reference link of our project. And thank you. And I will show the code of our project. Here the training set of our project. We have to import the datasets and import the libraries and pre-process the data. Here the training image preprocessing and validation image preprocessing, and we have to build a model using convolutional layers and compile the training phase. Here is our compiled output, and here is our training history by using epochs. Here is our evaluate the model, and here we have to save the model. Here the model saving is useful for representation of prediction Here is our calculating accuracy of model achieved on validation set. Here is our accuracy visualization, and here also we use the testing datasets. Like we have to train the data and test the data, means we use different collab links. Here is our testing datasets. First we have to import the libraries and the datasets. We use the datasets in the drive and we mount it and use the datasets for the project. Here the test dataset image processing, and we have to load the data and visualize the prediction in single image, and we test the model. And by using we deployed this project by using Streamlit. By using Streamlit, we deployed the project. The Streamlit is majorly used for deploy the projects for like machine learning projects or data science projects. Here we use the Streamlit as front end also, but not as HTML and CSS or too hard to uh, too easy to create, but we have to connect the back end and front end using Flask. But with Streamlit we easily create the front end and connect the uh, back end and front end. Here I will run the project. You have to open the new terminal and see, here is our project and here is our home button, and in this we have, here is our about the project. We import the data sets, and the data set contains the 100 train images and test images 10 and validation images 10 each, and we predict the fruit and vegetable, like we have to browse the files, and I have the a picture of banana, and here also we show the image as banana, and we have to predict it, and our prediction is banana. In case you have to detect the vegetable to show the image and predict it, our prediction is spinach. So thank you for your valuable time.